Good morning, my name is Letizia Bua and I work on renewable energy from biomass. Today I want to tell you something about biofuels. During this seminary we'll see what is a biofuel, what the European community says about a biofuel, how we can produce it and any involvement on biofuels. What is a biofuel? A biofuel is a fuel that is derived from biological materials. During this presentation, we understand which kind of materials. But first, I want to show something about the carbon balance of biofuels. In particular, all fuels, fossil and bio, emit some carbon dioxide during the combustion phase in engine. But for the biofuels, this CO2, carbon dioxide, is first fixed during the growth of the biomass. So we have a minor impact on CO2 emissions for biofuels compared to fossil fuels. What the European community says about it? In order to reduce CO2 emissions, the European community indicates a quantity for biofuels. In particular, there is a directive, Renewable Energy Directive, that fixes 10% of energy in transport sector for the 2020 from biofuels and electricity and hydrogen produced from renewable. Moreover, the RED suggests also a percentage of advanced biofuel. What is an advanced biofuel? We can see in the slide. Biofuels are all the same, this is the question, but the answer is not, because we can define three different generations of biofuels. In particular, the first generation, when the biomass for producing biofuel is in competition with food. The second generation is from a lignocellulosic biomass, so we have not competition with food. But moreover, the third generation is when there is a competition for food, but also for the land use. For example, for algae, we can cultivate algae in the sea or in other area not suitable for other cultivations. But first, I want to show you the actual situation of biofuels. We can see the production now of biofuels in the world, and we also can see that they are most of first generation, in particular from palm, from rapeseed, from sugarcane, and from corn. Now, we can see how we can produce a biofuel. So we have some different technological options. A big distinction is between biochemical conversion and thermochemical conversion. Under the biochemical conversion, we can see fermentation, digestion, and photosynthesis. For the thermochemical conversion, we have pyrolysis, liquefaction, gasification, and hydrotreating. Before to see the way to produce biofuel, we can mention the most famous biofuels. We have bioethanol, biodiesel or FAME, hydrotreated vegetable oil, HVO, biomethane, pyrolysis bio-oil, and biomass to liquid. Now we start from bioethanol. To produce bioethanol, we need sugars, and in general in this presentation you can see the molecules with in gray carbon atoms, in white hydrogen, and in red oxygen. The sugar for bioethanol derives from biomass. In particular, bioethanol is the most ancient biofuel, more or less, because we can see in the history some representation. This is for the ancient Egypt, with the biomass cultivation, the fermentation step, and the distribution. This is the process for producing wine by fermentation, but this is a kind of bioethanol. Now we can produce ethanol, not for wine but for fuels, from sugarcane. The sugarcane is subjected to a process with grinding and fermentation. In order to obtain the desired ethanol purity, we need a distillation step. Sugarcane is a biomass used also for food, so this ethanol is of first generation. Another possible biomass for producing ethanol is corn, and also in this case the ethanol is of first generation because, as I showed you before, these are biomass also used for food. The process for producing ethanol from corn is quite similar to the production from sugarcane, but we have another step, one more step, the saccharification step with enzymes. We need this step to make the sugar available for the fermentation. If we want an ethanol of second generation, we must use lignocellulosic biomass as starting point. This process is more complex because the sugar for the fermentation is inside the structure, and we can see that biomass is formed by cellulose, hemicellulose and lignin, and we need to break the structure to release the sugar for the fermentation. We see this step in this slide. The process is the saccharification. We have lignin, cellulose and hemicellulose in the biomass, in lignocellulosic biomass, and with the saccharification step we can break the structure and release the cellulose drawn in blue. So the cellulose can be used in a fermenter to produce bioethanol after this step. Another possible biofuel is the biodiesel or fatty acid methyl ester. Fatty acid methyl ester is produced from triglycerides. These triglycerides are obtained with a process of extraction, oil extraction from biomass. We can use different kind of biomass, for example, sunflower, rapeseed, palm, and so palm oil. And the oil is subjected to a process of transesterification and purification. So we obtain the fatty acid methyl ester and glycerol as coproduct. Another biofuel from the same starting point is HVO, Hydrotreated Vegetable Oil, because we start from triglyceride like in the other process. But in this case, the triglycerides are subjected to an hydrodeoxygenation. They are treated on a catalyst with hydrogen, and so in this way we remove the oxygen in red from the chains and rearrange the chains in order to obtain fuels. I wanted to show you two underway projects of Eni about HVO. The first in Venice, already started in 2014, and the second planned in Sicily in 2017. And in this case, we have the name of green diesel, that is the commercial name for HVO by Eni, produced by Eni. Also in this case, we have used oil from vegetable, like palm oil, for example, and so the HVO is a fuel of first generation. If we want to have a fuel of second generation, another time we must start from lignocellulosic biomass. So we can see that we produce HVO from triglycerides, but we can obtain triglycerides from biomass, from lignocellulosic biomass. In particular, the process is more complex, as we have seen some slides before, because we need to make the sugar available for the fermentation, so we need the saccharification step. And in this case, we can use this lignocellulosic biomass to produce with Saccharomyces ethanol, bioethanol of second generation, or with a different microorganism, oleaginous microorganism, we can produce microbial oil. And this oil is equivalent to the vegetable oil, so we can treat and obtain H2O, but this H2O is of second generation. We have seen something about biofuels of first generation and second generation, but what about third generation? We can have a fuel of third generation from algae, for example, because some microalgae have the property to store lipids inside the cell. In this slide, we can see some beautiful views of microalgae through a microscope, and we can see in the table the oil content of different microalgae. Only for example, Botrycoccus brownie can store up 75% of oil inside the cell, and this oil can be then extracted and converted to fuel. In this slide, we see the production process of algal oil. Algae needs carbon dioxide to growth, water and nutrients, but this feedstock can be recycled from a recycle, because the CO2 could be used from flue gases or flue gases of power plant, and the water with nutrients could be municipal wastewater, for example, because the nutrients are nitrogen and phosphorus, and we have them into wastewater. Then, after the cultivation step, we have an extraction to release the algal oil, and the algal oil could be upgraded to different type of fuels, for example, jet fuel, diesel fuel, and so on. You can see here the different oil productivity of algae, and there is a comparison with some other biomass, in particular corn, soybean, rapeseed, sunflower and palm. And you can see that the numbers are very different. The oil content of algae is very, very high, and so they are very interesting for this reason. But a disadvantage of the algae is the optimal cultivation zone. For example, you see in the blue box the optimal cultivation zone, and so not all the world is suitable for cultivating algae. I want to show you an example of pilot plant built in a Eni refinery in Sicily, and this pilot plant is for cultivating algae, 1 hectare, and the productivity was up to 100 ton hectare year. Now we move to another biofuel, in this case a gaseous biofuel, biomethane. Biomethane is produced from biogas with some purifications, because starting from biomass, animal manure, organic waste, in particular the organic fraction of municipal waste, for example, we can produce biogas in a fermenter. Biogas is formed by methane and carbon dioxide, so we can separate methane and use it for electricity production or for automotive sector. We have concluded the part of biochemical conversion, and now we move on the thermochemical to the thermochemical conversion. And in particular, in a thermochemical conversion, we have a biomass. We give heat to a reactor to obtain an energy carrier. gas, liquid or solid. More in detail, here we have two processes, thermochemical processes, for example, pyrolysis and liquefaction. In this case, for pyrolysis, we use dry biomass. For liquefaction, we use wet biomass. But the process is similar because we obtain a bio-oil in these processes, and then this bio-oil can be refined to produce liquid fuels. This is a pilot plant realized during a R&D project on liquefaction in particular, and we use wet organic fraction of municipal solid waste or food waste from food processing or sewage sludge. And in this plant we produce bio-oil. This bio-oil can be refined in another step, in a further step. The last process on thermochemical conversion we see now is biomass to liquid, BTL. In this case, we have a dry biomass and we convert the biomass into a syngas. Syngas is a gas, a mixture of hydrogen and CO, carbon monoxide, and this gas can be converted into liquid fuels through a catalytic process. In particular, the gasification process, the production of syngas, is known since the 40s, and this is a funny picture about a car with a gasogen, because during the Second World War was used this type of car, and it was possible to convert biomass in syngas. Then the syngas was burnt directly in the engine of the car. Now is better to convert this gas to liquid fuel through the reaction of Fischer-Tropsch. This reaction, this process was developed in the 30s by Fischer and Tropsch, and it is a catalytic process where the CO and hydrogen react to obtain hydrocarbons, preferably long chains. Because long chains? Because why long chains? Because a long chain is more flexible, because we can upgrade in different ways to obtain gasoline, jet fuel, diesel or biolubricant. Now, for the conclusion, I want to show you two projects, European projects, in which ENI is involved, because we work on biofuels with some internal R&D projects, but also with the participation to some European consortia. And we have a participation on in a project named FastCard on BTL process. And you can see in this slide the countries, the European countries involved in this project, and it is more or less all the Europe. And the second project is Cascabel on pyrolysis. I hope you enjoyed the presentation, and thank you for your attention.